Namaskar. This is Professor S.Lal, Professor of Mathematics and Computing in the Department of Science and Technology under the Faculty of Education and Methodology, Jayoti Vidyapeeth-Strong, University, Jaipur. Students, as per your curriculum and as per the session, today we shall discuss a very important fact of your bounds and convergence, and that is a strong and weak laws of large numbers. So you know well that what is number, how a number is represented on number lines. 5 is a number because 5 may be represented on number line. 7 is a number because 7 may be represented on number line, and if you say that 1000 is also a number because this may be represented on number line. Now, a strong and weak, this is, you can say, very interesting facts for you. A strong and weak laws of large numbers. So, actually, no laws is strong and no law is strong and no law is weak. But when we move to the concept of probability and random process, in that case we find that there are some laws which may be termed as strong, and there are some laws which are supposed to be weak. For the sake of the convenience of your study, I would like to share the material that is going to explain the concept of strong and weak laws of large numbers. So let us see what is the laws we are going to discuss. And I am sharing the material. You see the weak law and the strong law of large numbers. You are seeing on the right of the matter that is visible on the screen of your computer or on your mobile, that James Bernoulli proved the weak law of large numbers. Weak law of large numbers, that is in short abbreviated. In short, it is abbreviated as WLLN. WLLN means weak law of large numbers. Around 1700, which was published posthumously in 1730 in his treatise Ars Conjecturendi. Poisson's generalized Bernoulli's theorem in around 1800, and in 1866 T. Chebyshev discovered the method bearing his name. Later on, one of his students, Markov, observed that T. Chebyshev's reasoning can be used to extend Bernoulli's theorem to dependent random variables as well. In 1909, the French mathematician Emile Borel proved a deeper theorem known as a strong law of large numbers that further generalizes Bernoulli's theorem. In 1926, Kolmogorov, you know, Kolmogorov is termed as the father of probability theory, derived condition that that were necessary and sufficient for a set of mutually independent random variables to obey the law of large numbers. So, now let capital X be independent identically distributed Bernoulli's random variable such that Pxi is equal to P, where the probability of Xi is equal to 0 is equal to 1 minus P is equal to Q. We know that P plus Q is equal to 1. And let small k is equal to x1 plus x2 plus x3 plus xn. You have already seen this result in the previous discussion. Represent the number of successes in n trials. Then the weak law due to Bernoulli states, as we have seen in the previous talk discussion, this is probability of k by n minus p. Modulus value is greater than epsilon. The whole value is less than or equal to pq divided by n epsilon square. You can take it as, since this is 13.1, this is part of the slide, so you can take it as equation 1. And the ratio, total number of success to the total number of trials, tends to p in probability as n increases. A stronger version of this result due to Bernoulli and Catelli states that the above ratio k upon n tends to p not only in probability but with probability 1. This is the strong law of large numbers, SLLN, strong law of large numbers. Now, what is the difference between the weak law and a strong law? This is a question that might be in your brain, in your mind, that might be in your understanding, that what is the difference between weak and a strong law of numbers in probability theory. Then the answer of that your query and that your question is that the strong law of large numbers states that if set of epsilon n is a sequence of positive numbers converging to 0, then the probability you have obtained at its sigma value that starts from n to infinity must be less than infinity. And from Borel-Catelli lemma, when this holds and satisfy the events n is equivalent to like that, this result can occur only for a finite number of indices in an infinite sequence, or equivalently the events k upon n minus p, the modulus value of that is less than epsilon n, occur infinitely of n. The event k upon n converges to p almost surely. So students, I hope that you have understand that just you have to define the definition that what is strong and what is the weak numbers in the sense of probability, the basis of their result. And for your kind information, this session is powered by digital version 2.0 of Jayoti Vidyapeeth-Strong University. I suggest you, in case of any query, you should read it to the, you should write your comment to the inbox, and I shall try to resolve your query from there. And I assure that I will be attaching this paper, this PPTs, this material with your portal so that you may write the fact of all the things. And in case of any doubt or any problem, we can discuss in our interaction session. So thank you for enjoying and listening this lecture. Thanks a lot.